Okay, so here's the recording. I'm just going to go back here. We covered a little bit of triangle terminology, if you don't know what that is. And here is the formulas for Pythagorean theorem to solve for any one side. We are starting this examples over here. And we left off with B. Did everybody get B at 1.25 meters? Excellent. So again, we have this D here. We have another one the same. So it's going to be 6.798 meters squared minus 3.1 meters squared is equal to B squared. So B would equal, and I could type that right out in my calculator in one shot, 6.798 squared minus 3.1 squared equals shift square root. B is going to equal 6.05 meters. And I might be moving a little bit fast with this, but you know, it's review. The next one here on this list is E right here. And I have C and I have B. So it's going to be 836 squared minus 331 squared is equal to A squared. So A equals 767.68 mils. Yeah, does everybody concur? Okay, take a minute and do F, G, H, I, J. Take 5 minutes. Do these, write your answers down. I will write in the answers here and just to see if you got them correct. So you do it now. See if you can get it done. These next few from F, G, H, I, J. Okay, so there's all the answers for that particular sheet. Just want to make sure you got those answers. Now I'm going to go and we're going to talk about some more triangles here. So in Pythagorean theorem, we again talk about right angle triangles. Now, here's the thing about right angled triangles. If I have an angle that is 45 degrees, that makes this angle 45 degrees as well. Because every triangle comes up to 180 degrees. 90, 45, 45, 180, right? So what I'm going to tell you that in a right angle triangle, I should write this out. In a right angle triangle, that has 45-degree angles, the run and rise are equal. Remember, we called this the rise or the offset, and we called this the run. In a 45-degree right angle triangle, the rise and the run are always equal because basically it's just a exact square, right? And that means all the sides are equal. if the angles are 45 degrees. They're all equal. Now, if the rise and the run are equal, then the travel here, the travel in a 45-degree right angle triangle, the travel is always 1.414 times longer than the run or rise. Now, that 1.414 doesn't come by accident. We use Pythagorean theorem for that. For example, Pythagorean theorem says a squared plus b squared is equal to c squared. Well, listen, if the run is 1, then the rise has to be 1. So that's going to be 1 squared plus 1 squared is equal to c squared. 1 squared is 1, 1 squared is 1, so it's going to be 2 equals c squared. And if we do square root, that means c is equal to 1.414. So we have this all the time, that in a right angle triangle, the travel is always 1.414 times longer. Does anybody know the 3-4-5 rule?
I've done it. I just forget about it. I haven't done it in like 6 years.
Okay.
Not like sheet metal.
The 3-4-5 rule can be used on the job site to figure out if you're working with a perfect right angle. So if you're laying out pipe, etc., and if you're not working with a right angle, well, then your calculations are going to be bad, right? Because you're not working with square walls. So you want to know if you're working with square walls, square floors, whatever, any kind of situation. And we could use the 3-4-5 rule. And the 3-4-5 rule is simply this. If you have a right angle and you want to know if that's a perfect right angle, what you do is you measure out 3 feet, 3 meters, whatever. I don't care what it is. And then you measure out 4 feet or 4 meters. And then the distance across here is 5. And if the distance across those 2 points are 5, then you're working with a perfect right angle. And Pythagorean theorem tells us that. If I said 3 squared plus 4 squared is equal to 5 squared, well, we can figure that out. Look, at 3 squared is 9, 4 squared is 16, 5 squared is 25. Look at that, it works. So on the break, which we're going to take right away, I want you to get a tape measure. Or a ruler even, and do a 3-4-5 rule on something that you want to see if it's a perfect square. And then you can figure that out to see if it's a perfect square. You can use the corner of your desk, just mark out 3 and 4 and see if it's 5 straight across. And that way you know if you're working with a perfect right angle. All right, so let me share my screen. We just left off with talking about the 3-4-5 rule. Hopefully you did that. Did anybody do it? Kind of see if it works? No?
The door's not square.
Well, that's right. Your wall's falling down. It's crooked. It's just basically for layout. When we do layout of bigger projects, we want to make sure we're working with right angles, because if we don't have a good right angle to start from, all your measurements and calculations are going to be slightly off. So it's good to know to start. All right, so on my screen, we talked about that this portion right here, and this is very important because we're going to lean on this very heavily. Right angle triangles that has a 45-degree angle, the run and rise are equal. The travel is always 1.414 times longer than the rise or the run. So I want to also talk to you about fitting allowance. Fitting allowance states that the throw minus the thread engagement is equal to the fitting allowance. Okay. So that's what we do. Now, in our IPT Pipe Trades Handbook, let me just I have it here. Hang on a second. I'm going to stop sharing for a second here and pause this. Okay, I'm going to share this screen. So in your Pipe Trades Handbook here, what you can do is I'm going to scroll all the way to screwed fittings, and it's going to be way down here in page 100 and something.
62.
Yeah.
Close to ish.
Fittings.
Boarding.
Let me get to screwed fittings, copper fittings, threaded fittings. Look at there. So these are threaded fittings. As you can see in this particular one here, A is given measurement, and down here, T is the thread engagement. So A on this is the throw and T is the thread engagement. Okay, can you see that right there? So when we're going through this book, when you have to look up fittings, I really want you to know where to find A and T. Now, I'm going to then scroll up to the next page. Now on here, if we have a 1-inch fitting, can everybody see that okay? Let me just get it a little bit bigger here. There we go. So if we are using a 1-inch screwed threaded fitting, standard malleable iron, here is A. So if we said that a 9D has a throw of 1.5 and a thread engagement of 0.58, what now is my fitting allowance for a 1-inch screwed fitting?
0.92.
That's exactly correct. It is 0.92 inches is my fitting allowance. Okay, so that's how we use this table. We take the dimension that we want on the fitting and take off the thread engagement. And that goes for all of the screwed fittings. So I'm going to go back up to this next, right here. As you can see, even on a T, right here, we have A. Oh, we have A minus T, and then I get my fitting allowance. So that's just a side note on the IPT book. So throw minus engagement is the fitting allowance. So let's go back to my whiteboard here. And we're going to talk about, or trying to solve, first off, for some right angle triangles that are 45 degrees. So these are 45-degree right angle triangles. Okay, you can see it there. So if my set offset, that's this line, is 10, what is my run going to be? Just off the top of your head, you should know it.
10.
And they're the same. The set or the offset and the run are the same in a 45-degree right angle triangle. And the travel is always 1.414 times longer. So this is going to be 1.414. There you go. Inches. Pretty straightforward, yes?
Mhm.
So look at B. So if the run is 1 foot 4 inches, that means the set or the offset is also 16 inches. I just made the leap there that you knew that 1 foot 4 is 16 inches. I would assume you could do that. And then of course the travel is always 1.414 times longer, making this 22.624.
No,
No,
20. Right? No, you said it's 4 point what?
1.414 times longer. Remember this number.
So if it's 16, wouldn't it be 17?
16 times 1.414. Can you do that on your calculator? I mean, I don't even know.
Didn't you just add it?
We multiply. We take our run or our rise or the offset and multiply it by 1.414. It's always 1.414 times.
Yeah, you're right. That's the answer.
So in this case, number C here, we have 30 inches, right? So 2 foot 6 is equal to 30 inches. Now, if I wanted to get, so this is the travel over here is 30 inches. If I wanted to get the run or the offset, I would simply divide by 1.414. So this is going to be 21.216, 21.216. Everybody following along with that? Does everybody concur? Okay, I'll do a couple of more of these with you and then I'll let you do the rest on your own. So if D is 3 foot 5, that makes this 41 inches, right? Because 36 plus 5 is equal to 41 inches. These two are the same. And now the travel is always 1.414 times longer. That's 57.974 inches. Okay, now I want you to take a few minutes and do E, F, G, H, I, and J by yourself. Okay, so now I want to talk about an offset that really now becomes more appropriate for us, okay? So let's have a look at this particular picture. I have A here, B, I want the run. I have the center to center travel. I have a throw. I have an engagement, a fitting allowance, and an end to end travel. So you should know that C to C means center to center, right? You should know that. You should know that A to E is end to end. We have face to end, that's face of a fitting to end. We have center to face. We have all these different kinds of little things that we use to describe our measurement. So you should already know that some of that stuff. So what I'm going to do here is we're going to discuss and figure out some of these measurements just by measuring the center to the top of the wall here. So there's a ceiling and the center line of the pipe. So they said A is 22 inches in this first example. B over here is 10 inches in this example. And we want to find the run and the travel. So what we do here is this, from center of this fitting to center of there, is the travel. That's the travel that they're talking about there. This is the rise and the run. And there's my right angle triangle. So if we have a run right here, let me just use a black color here. If this is my run in this location, can I tell how high that run is? Can I, or how long it is? Can I figure that out?
Would you do 22 minus 10?
Oh, that is fantastic. So this has to be 12 inches, doesn't it?
And if that's 12
forward?
inches, the other one's 12 inches.
Okay, yeah, but I only need one. And then I can get my travel right here, my center to center travel. How do I do that again?
Times it by
1.414.
1.414, you got that right. So my travel is 16.96 inches. Because we took 12 and multiplied it by 1.414. Listen, if you guys are doing half-inch copper pipe, then mathematically, you don't have to do this too much, right? You can just figure it out. But if we're working with 10-inch steel pipe, guess what? You're going to want to do it mathematically. Let me tell you that much. All right. So now the fitting allowance that's down here, it says that the throw is 2 and the engage, or throw is 3 and the engagement is 2. What does that make my fitting allowance?
1.
Yes, 1 inch. Remember, the throw minus the engagement is equal to the fitting allowance, 1 inch. Now, I have a center to center measurement of this pipe at 16.96. What is my end to end? So this is my cut length. What is my cut length of my piece of pipe?
15? No.
How many fittings do I have?
2.
Okay. What's my
So you
end?
go 16 minus 0.96 minus 2.
14.96 is my cut length. I minus off 2 fittings because I have 2 fittings here.
Oh.
Right? Gives me my end-to-end cut length of my piece of pipe of 14.96.
Makes sense.
Awesome. Excellent. Okay. Let's go to the next one here. Everybody see B at this one, B here? We have 35 and 18. What does that make my run?
17.
17. What is my travel?
1 second.
All right.
24.03.
That's right. And now I have a throw of 1.5 inches, an engagement of 1, which makes my fitting allowance a 1/2 inch. And then my end-to-end travel, I have 2 fittings, so I must minus 2 fittings. So that's going to be 23.038 is my end-to-end cut length measurement.
I can't tell you how many times in the field I forgot to take off fitting allowance and gone and been like, why the hell hasn't this pipe fit?
Yeah. Well, once you cut it twice, it's usually still too short.
Yeah.
Yeah. Or, I mean, Stu, you ever gonna get the pipe stretcher out of the truck or what?
Oh no, but I sent my buddy Jerem to go do that one and let him looking for polka dotted spray paint for probably an hour one day. It was hilarious.
Well, here's the deal. My old man's a plumber. So somebody on one job that I was on as an apprentice said, oh, I need the pipe stretcher. Go to the truck and get it. Ha ha ha. And I'm like, okay. And I left for the day.
That's hilarious.
And then I came back the next day. He's like, where'd you go? I said, hey, I went to the shop. I went and asked the boss. He's like, no way. Oh my God, what happened? I said, you're an idiot. I'm never doing that again.
That's hilarious.
I had a journeyman tell the laborer to go find some fallopian tubes.
Oh my God,
He
fallopian.
spent 2 hours asking everyone for fallopian tubes.
What about, have you ever done the whole go find a bubble for my level? That one's a good one.
You see,
They'll
you
run that.
get away with some things, but you got to be careful because there's people that are smarter than you out there.
There was one time one of the journeymen told the apprentice to go get a cardboard box and catch the sparks. Yeah, that journeyman got fired later.
He got fired?
The journeyman got fired because it was a safety hazard technically, because the guy was literally catching sparks from the welder.
Oh my God.
It was bad.
Yeah. See, be careful out there. You're
It's
gonna play.
like, go get the red dye to test to see if the hot water tank's actually pumping out the hot water on the right side.
Be careful out there. All right, let's get back to this. C over here. So this is what I'm going to do. I'm going to let you guys kind of help us out here. So going through the list using your annotate button, fill in the blanks. Let's see how you do. Everybody have a shot at something. Do one. Start from the bottom, start from the top. Start filling in the blanks. You guys can do that. And I'll put check marks or X marks on the spots. Fill in the blanks on the screen. Use the annotate button in Zoom. Okay, 240. Let's see. That's C. That's correct. That's right. That's right.
Why do I not have this button?
That's right. Be at the top of your screen.
Yeah.
There's a little options button.
Yeah. Options.
That's correct. Brad, you're gonna want to fix that one. Does that say 452, Cody? Yeah, okay.
So for E, I'm just gonna divide 14.5 by 1.414, correct?
No,
42 is already there.
we
Stu.
times it. We times it.
Right.
This is the run. Remember, this is the run. This is the travel.
Thank you.
So divide 14.
That's correct. You guys do that, I will pause the recording.